Namaste, and welcome back to JEE Mathematics with Typical Monk. This is class 34, Integration. If the derivative teases a function apart to find its rate, integration puts it back together. Run differentiation backwards, and you get the antiderivative, the indefinite integral, a whole family of functions differing only by a constant. Pin down two limits, and it becomes a single number, the area trapped under the curve. The fundamental theorem of calculus ties these two ideas into one, and from it flow areas, volumes, and the solution of differential equations. Learn the standard integrals and the three great methods: substitution, by parts, and partial fractions, and integration becomes a craft you can trust. Today, the integral, its methods, and the area under a curve. One idea at a time. Here is what you will master today. First, the indefinite integral. Second, the standard integrals. Third, the methods of integration. Fourth, the definite integral. And fifth, the fundamental theorem. One idea at a time. Let us set the foundation. Integration. It is, quite simply, the reverse of differentiation. Two kinds. The indefinite integral gives a function plus c, and the definite integral gives a single number. The area. The definite integral is the area under the curve. Master line integration undoes the derivative and measures accumulation. Now look at the picture. The definite integral. The indefinite integral. It is the antiderivative, the reverse of differentiation, plus a constant. The definite integral. It is the area under the curve between the two limits a and b. The fundamental theorem. It equals f of b minus f of a, where f is any antiderivative. Signed area. The area above the axis is positive. The area below the axis is negative. Now, the standard integrals. Learn these by heart. The power rule. The integral of x to the n dx equals x to the n plus 1 over n plus 1 plus c, provided n is not minus 1. The reciprocal. The integral of 1 over x dx equals the natural log of the absolute value of x plus c. The exponential. The integral of e to the x dx equals e to the x plus c. Trigonometric. The integral of sine x is minus cosine x plus c, and the integral of cosine x is sine x plus c. Now, the three great methods and one more. Substitution. Change the variable to simplify. It is the reverse of the chain rule. Integration by parts. The integral of u dv equals uv minus the integral of b du for a product of two functions. The Elate rule. Choose your u in the order: inverse, logarithmic, algebraic, trigonometric, exponential. Partial fractions. Split a rational function into simpler pieces, then integrate each. Trigonometric. Use the identities to reduce a difficult trig integral to a standard one. Now look at the picture. The standard integrals gathered together. The power rule. Add 1 to the power and divide by the new power. The reciprocal. The integral of 1 over x is the natural log of the absolute value of x. The exponential. The integral of e to the x is, beautifully, e to the x again. Trigonometric. Sine integrates to minus cosine, and cosine integrates to sine. Now the definite integral, in full. The definition. It is the area under f between the two limits a and b. The fundamental theorem. It equals f of b minus f of a. A number. Unlike the indefinite integral, it carries no constant. It is a single value. Properties. Swapping the limits changes the sign, and the integral from a 2a is 0. Substitution. You may use it, but remember to change the limits when you change the variable. Now a few properties that save time. Reversal. The integral from a 2b equals minus the integral from b to a. Split. The integral from a 2c equals the integral from a 2b plus the integral from b to c. Even and odd. Use the symmetry of the function over the interval minus a to a to simplify. Now, match each integral to its result. The integral of x to the n goes to x to the n plus 1 over n plus 1 plus c. The integral of 1 over x goes to the natural log of the absolute value of x plus c. The integral of sine x goes to minus cosine x plus c. And the definite integral goes to f of b minus f of a. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. The definite integral is the area under the curve. Correct. Statement 2. The integral of 1 over x is 1 over x squared plus c. Wrong. It is the natural log of the absolute value of x plus c. Statement 3. The integral of e to the x is e to the x plus c. Correct. So the answer 2 are correct. Statements 1 and 3. The trap is the integral of 1 over x in statement 2. Now, the 2 mistakes that quietly cost marks. The truth. The indefinite integral always needs the constant of integration, c. The trap. Forgetting the constant of integration. The second truth. The integral of 1 over x is the natural log of the absolute value of x, not the power rule. The second trap. Applying the power rule when equals minus 1, that is the one case it fails. Now test yourself. Answer in your head before the reveal. That is how G-speed is built. Here we go. Question 1. The integral of x to the n. X to the n plus 1 over n plus 1 plus c. Question 2. The integral of 1 over x. The natural log of the absolute value of x plus c. Question 3. The integral of cosine x sin x plus c. Question 4. The definite integral equals f of b minus f of a. And question 5. The rule for a product, integration by parts. Let us gather it all in one breath. Integration reverses differentiation. The indefinite integral gives a function plus c. The definite integral gives a number. The methods, substitution, by parts, and partial fractions. The definite integral is f of b minus f of a, the fundamental theorem. And it measures the area under the curve. Next class, differential equations. Putting it back together, integration is the quiet counterpart of the derivative, where one pulls a function apart, the other builds it back, gathering up an infinity of tiny pieces into a whole. As an indefinite integral, it returns a family of curves, always trailing its constant. As a definite integral, it returns a single number, the exact area beneath a curve, delivered by the fundamental theorem as f of b minus f of a. Learn the standard forms, reach for substitution by parts or partial fractions as the shape demands, and never lose that constant. Next class, we'll let derivatives and integrals meet in an equation, differential equations. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack JEE. I will see you in the next class.